Morning once more. The information that I wrote here is related to the example that you did with Mr. Luo, your class example. He said this was a class example for maybe I'm confusing you because we have to cover these two sessions. Um, check it, guys. I don't want you to get lost. It's randomized block design. You don't know about this example when you're dealing with randomized block design, where you're having three treatments. You're given 15 values, three treatments, and the means for the three treatments. It told me these are the means for the three treatments. And you are ANOVA table, you rejected that there is a difference between some of the treatment means. So we have to use those methods again, the one that we used um, when dealing with CRD, the Newman curves, the Duncan, the Cheeky methods. We have to also apply those methods here and also indicate how can you get their confidence intervals. So I'm here for that. So I have to do the confidence intervals and the pairwise comparison methods under the randomized block design. And again, I must show you the formulas that can use used when we are having blocks by treatment interaction effects. So it means we're going to look for another example where we can use the same methods again, but under a different what under a different problem where there is an interaction. Do you remember this example, guys? Leaders, do you remember this example that you did with Mr. Wall? He said it's about
Yes.
the employee. Yes. So don't be confused. Means now we're going back. We want to conclude the chapter now. So we're going back to randomized block design. This is a class example, right? Randomized block design. You did this problem with Mr. Luo. You said your F was 12.9 and um, the degrees of freedom of error is 8. You know, when we want to do pairwise comparison, these are the information. This is the information that we need, isn't it? We need the MSE. We need the degrees of freedom of errors. We need F calculated. We need to know how many treatments do we have. So T is equal to 3. Yes.
Sir, good morning, sir.
Money.
Uh, I think those values are the totals, not the means. 24.5 and
Oh, they're not the means, right?
yeah, they are totals.
Total. Thank you very
For
much. Give me the
yeah, for
correct.
it was for
But
block, I think. It was for no, it was for treatment.
yes, thank you very much for that. So it means I missed that one. So the correct ones is I think is this other information. So it means the way you gave me it was confusing there. Um, well, let me give you the values now. Thank you for that, my brother. We're about to mess up with everything. I think the correct one is 4.9. Is it, my brother?
Yes, that's correct, sir.
4 and 3.44. Isn't it, my brother? This is the correct info, right?
Yes, correct.
Thank you. So let me start with the method that Mr. Leo used, which is the LSD. We need to know how to use these four methods. So let me repeat what Mr. Leo did. The LSD method, this is the first method. We have to use this example to apply all these four methods. The LSD method, you know, is given by LSD is given by T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over B, right? And then you are going to compare this with y bar I dot minus y bar I prime dot. Why am I saying I prime dot is because I'm simply indicating that the other mean is not the same with what? The first mean. So you are comparing two means there. So the confidence interval for this will be given by, you see this part here where we have the absolute values. So the confidence interval for this method will be given by I'm coming, my brother. Oh, sorry. Y I dot bar minus y I prime dot bar. These are the brackets, plus or minus LSD. Yes, I'm listening. I'm listening.
Oh, sorry. I was confused. I thought maybe we are using the block means. I see the
No, no, no,
treatment.
no, no. No, these are, remember, uh, can I explain something maybe before? Let me go to the next page. My sister, we're here, right? Uh, uh, suppose we have this following layout. Blocks. We have 1, 2, 3 up to B block, isn't it? And this side we have the treatments, which is 1, 2, 3 up to T treatments. How do you find, my sister, the person who was just talking now? How do you find the sum of the first treatment?
I'm
How do
going
you
to
find?
I'm going to add from that row for the
Yes,
treatment itself.
you're going to add the value for this, which is here, this one, up to what? Up to what? Up to what treatment? Up to the B block, isn't it?
Yes.
You see, for you to find the value, the sum of the first treatment, you are adding the values from each treatment, from each block, sorry. Remember, in this case, we have B blocks. So when you want to find the sum of the first treatment, you are going to add the values from each and every block, because this is block 1, block 2, block 3, up to B block. That is why even when you check this one, my sister, when you check, so the first value here will be y1 dot, because you are focusing on the what? This is the sum. So that is why even here, when we divide, because you are going to what? My sister, you are going to the B block, isn't it? You are going to the B block. That is why even when we find the confidence interval, sorry, the pairwise comparison, we are dividing by what, my sister? You see what we're dividing with? We're dividing with the B block.
Yes.
Isn't it, my sister?
Yes.
Yes. So suppose even though I won't ask you, suppose we'll ask you to find, to compare the means of the blocks. Do you understand now? compare the means of the blocks. What would be the formula, my sister? The LSD, if you are comparing the mean of the blocks, it would be what? T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over what? Let me go to the next page, that page. Over T, because when you want over T, because when you want to find the sum of the first block, you are summing the values to what? To the T, isn't it, my sister? So that's how you know you are dividing by what. Or you'll be guided by, if the layout is like this. If the layout is like this, my sister, you remember the model is Yij equal to mu plus tau I plus Bj plus Eij. Understand the meaning of this I and J. I, you are saying it goes with what from this given problem? You are saying your I will go with what? Your I will go with the treatment, isn't it?
Yeah.
And then your J, you are saying it is going to go with the blocks. Provided the layout is like this, my sister. If I change the layout, I decide to switch the two. I take the blocks this side and the treatment the other side. You cannot say I goes with the blocks, isn't it? If I switch the two, now I will go with the blocks. Treatment will go with what? The J. So allow me to go back to that class example. But Mr. Lebo told me that you covered the thing first. You covered this part with him. So any question based on this? So this I said we will divide by T. If you are comparing the means of the blocks, you divide by what? By T. So the confidence interval for when you are focusing on the treatment, the confidence interval is, here's the formula here. Yes?
So the treatment means on that table that you do, are they not going to be the ones?
Please raise up your voice. I cannot hear you, my sister.
The treatment means, are they not going
Yes.
to be the ones on the right on the table?
I'm not sure if it's my speaker, my sister, or it's from your side. Can you please repeat the statement?
The treatment means that we're supposed to compare. Are they not going to be the ones on the right?
Based on what? Based on my table.
Yes.
Based on this table.
Mm.
Yes, the treatment based on this table. If we have the treatment here, and then we have the blocks here. The means that we are going to compare is the means that we are going to write here. Okay. Because these are the means for the treatment, isn't it, my sister?
The ones that you wrote.
The ones that I wrote. The one that I wrote. I assume is this means. But it depends on how is your layout, my sister. Or it's fine. Let me spend more time on the layout because the layout is very important.
The thing is, on the example, those values are for the blocks.
So it means your layout was like this there. It's fine. Let me show you how was your layout.
That way, it's the way that you wrote it. But then the values are for the blocks.
How do you get that, my sister?
No, I think she's having the same confusion that I had. Our layout is not this one.
Yes. So I want to write the layout that Yana she's looking for. Your layout, my sister, it depends with the question. Let me write the layout, my sister, related. If Mr. Lobo decides to use the other thing, your layout, my sister, is like this. Oh, I want to use black. Block. Oh, sorry. Block. How many blocks were you having?
3.
5. 5.
1, 2, 3, 4, 5. Isn't it, my sister? And then treatments, you have 1, 2, 3, isn't it? So you are having values, my sister, here. You are having values here, isn't it? I don't know the exact values. Can I just write any values? Let's say here you have 2, 6, 7, 9, 12. 2, 4, sorry, 4 and 7. The value that you are going to write, my sister, here, isn't it, my sister, is you summed what? You summed the values from each and every block, isn't it? So the value that we are going to get here is from the first block, the second block, the third block, the fourth block, and the fifth block. What you are going to write here. So your layout now, the model, when we ask you to write the model, you cannot write the model like this. Now this becomes wrong. Your model now, which one was J? Is Yij, isn't it, my sister? Which is equal to mu plus tau j plus beta I plus Eij. Do you understand, my sister, now what is happening?
Yes.
You see what is happening here now. Now blocks, I goes with the blocks, isn't it? Because it's the row. Treat this thing Ij as the row and column. This row and this is column. Do you understand, my sister?
Yes.
So what is your row here? What is your row here? Is it a treatment or a block?
It's block.
It's block, isn't it? So blocks move from 1 to what? 2, 3, 4, 5, isn't it? J move from what? 1, 2, 3, because it's treatment 1, treatment 2, treatment 3. So you have B is equal to 5, T is equal to 3. Do you understand, my sister? You are guided by the layout. The layout is the one which is guiding you. So it means Mr. Lebo's problem was like this, isn't it? So it means even when we write the formula now, if the layout is like this, if we want to find the LSD, the LSD will be given by T alpha over 2. The LSD of the means is in the degrees of freedom of error multiplied by the square root of 2 MSE over what? Over B. Isn't it, my sister? You compare this with what? Because you want the means for what? The means for the treatment. You get it, my sister? This will be Y dot J minus Y bar dot J prime. Why am I using J now? Because my treatment goes with the what? On the what? On the columns. That's why I have to write the formula like this. It's different from what I wrote before, isn't it, my sister? It's different from this part. Can you see it? Because this one is, you write it like this provided your treatment goes with the rows. You understand, my sister? Any question based on that? Any question, please? Yeah, so the issue of layout is dangerous. You must be careful. Understand the layout. The secret is from the layout. If you understand the layout, you are done. So now, since I gave you the means there, but again, it's not a must for you to. It's not for a must for you to indicate that you wrote your formula will be like this. Make sure that you use the correct means. Make sure that you use the correct means. What you must look for is the means for the treatments. the means for the treatments. Please, so when you're given the problem, if the treatments are, if the treatments are like this, 1, 2, 3, 4, 5, it means the means for the treatment will be what? Will be this side, isn't it? If the treatments are this side, it means that the means for the treatment will be on the other side. Do you get it, leaders? Understand that part, because immediately you use the wrong means, you are out. So understand the way, if the treatments are row wise, where will you find their totals? If the treatments are column wise, where will you find their totals or the means? Allow me to go back to that part, what I was explaining. So let's apply this. From there, we move to the taking method using the same example. So I will save this. I will save this information and give it to you guys. You don't have to worry. I will share these handwritten notes with you. Class rep must work with me. I will try to make sure that I write things that are clear so that you can be able to follow. So I will share this immediately after the class, in case someone want to revisit these things. So let's continue, leaders. Let's continue with our example. Now we have those three means. Let's apply the formula. So the issue of layout is applicable for all the sections. You must understand the layout. So now let's do this one, guys. What is let's do the pairwise comparison now. From there, we'll move to the confidence intervals. Can someone give me those means? Let me write them nice here. Give me the means again.
4.9.
Treatment 1 is 4.9. Treatment 2 is 4. Treatment 3 is
3.44.
3.44. MSE
0.210167.
Thank you. So let's use the LSD method, guys. What is your value there? What are you getting when you go to the table? I said T, it will be T. Oh, degrees of freedom of error. This is very, very important. We said this what? It's 8, right?
8.
So we're going to check alpha, assuming that we're using 5%, multiply by whatever you get from the table. You multiply it by the square root of 2 MSE over B. We agreed that you said we have 5 blocks, right?
Yes. Yes, sir.
5 blocks, 2 multiplied by MSE. What is the tabulated value?
2.306.
Oh, you have it. Okay. It's what, my brother?
2.306.
Okay. Thank you very much. 2.306. My brother, I'm missing the second number.
2.306.
So what is your answer, guys, here? What is your LSD value?
0.66.
The final answer?
0.669 or 0.67.
Thank you. So let's compare now. Let's compare T1 minus T2. What is the value? 0.9, isn't it? 0.9, which is greater than LSD, isn't it? T1 minus T3.
1.46.
1.46 is also greater than 0, it's also greater than LSD, isn't it? T2 minus T3.
0.56.
0.56.
56.
This is less than LSD, isn't it? So this is significant, this is significant. Isn't it, guys? So when you want, so this is fine, isn't it? Now let's go to the what? Let's do the same, but now focusing on what? On the confidence intervals. Using the LSD method, what would be the confidence interval? This is going to be what? Mean of y bar dot minus. Oh, since you said the layout is different from, so it's supposed to be like this. This is a dot, you know? Based on your layout. So I don't want to confuse you when coming to the means that you're supposed to use. You see, these are not the absolute values, guys. These are not the absolute values. These are brackets. So you will say 0.9, mean 1 minus mean 2 is going to be positive or negative. It's the positive, isn't it? T1 minus T2 is positive, plus or minus LSD. What is the answer? Now we're finding the confidence interval. We're expecting two values, lower limit and the upper limit.
Sir,
Yes,
sir,
I'm listening.
aren't you supposed to compare the two means?
We're comparing.
So how did you get 0.9?
Let me reverse the question. How did you get this 0.9?
Oh, okay.
Confidence interval between T1 and T2. Confidence interval between T1 and T3. Now another confidence interval, it will be what? Between another confidence interval that we'll need will be between what? T1, T2 and T3. Isn't it, my brother? So now I'm
Yes.
asking you, give me the confidence interval between T1 and T2.
It's
The
0.
difference is 0.9. I'm trying to show you that you must be careful. Here we took into consideration the issue of what? Absolute values, isn't it? So with the confidence intervals, the absolute values should disappear. So what is the value there?
It's 0.231.
The lower limit, right?
Yeah.
The lower limit.
Yes.
0.31. The upper limit.
Is
No, it's
0.231.
0.231.
2, yeah.
Yes.
0.231. And the upper limit?
1.568.
1.5.
So you see, whatever the LSD is saying, even the confidence interval is saying the same thing, isn't it? As long as 0 is not included in the confidence interval, it means the two means are not the same, isn't it, guys? Since the 0 is not included on the interval, so it means there is a difference between those two means. Let's go between treatment 1 and treatment 3. Treatment 1 and treatment 3, guys. Let's do the same. Are we when we want to find the difference, is it the negative answer? 4.9 minus 4, no, 4.9 minus 3.44, you said is 1.46. It's positive, right? Because 4.9 is bigger than 3.44. If it was negative, we have to write it the value, negative value. So this one, 1.49 or 46, sorry, plus or minus 0.669. Now we're finding the confidence interval between T1 and T3. What is the final answer?
0.791.
And the upper limit?
2.129.
Again, you can see the values are all positive, isn't it? So it means there is a
Says
there
it's
is a
2.129.
one. Oh, sorry. 129.
Yeah.
And then the last one, I won't write the values. What is the confidence interval between T2 and T3?
Minus 0.109.
0, 1, 0,
Or 0
109.
is negative 1.4. That one. So
the lower
we're
limit
on.
is what? Are you not saying it's negative 0,
It's negative
109.
1.09 and
and the upper limit?
1.0. Yes, and the upper limit is 1.229.
1.229. You see, guys, this one includes 0, isn't it? And we agreed that we saw it even from what the LSD that min 2 and min 3 are the same, isn't it? They don't differ. Min 2 and min 3 are the same. Also confirmed by what? By its confidence interval. So when you are writing a test, you may be asked to use the confidence intervals to indicate which means are the same or which means differ, isn't it? So if you can check, let me emphasize something here. Check the formula of the confidence intervals. The only difference between this formula for the pairwise comparison and this formula for the confidence interval, the only difference is what? Is that you're going to get rid of the greater than sign and remove the absolute values, isn't it? So as long as you know the LSD part, automatically you must also understand how to construct its confidence interval. The reason why I'm saying this, I want you to construct the confidence interval of the next method, which is, yes, my brother or my sister, I cannot see
Yeah.
you guys.
The
Yes.
LSD which we are using is the same as the margin of error which we know is the notion of
Yes.
statistics.
Yes. But remember these formulas, they keep on changing. Like the one that I'm coming with now, the one that student ignored during the what our test, before our test. There is a method that when you guys you're busy setting your own test, you said he won't bring this one, he won't bring this one, and then unfortunately it was there. uh, yes, I'm writing those means again. Yes, I'm listening.
So do we also perform comparison for the blocks?
No, unless if we ask you, but in most cases we're focusing on the treatment.
All right.
I'm not sure what was the agreement between you guys and Mr. Luo. I don't know because that
Because
piece.
we don't want to be surprised in a test to say.
Oh, even Mr. Luo didn't do it.
Yeah.
No, you don't have to worry, leadership. Relax. I'm writing that information again so that we'll move to the next method, which is the takey. This takey method nearly created problems during our test. Degrees of freedom of, this is the information that you know now. You said it's 8. So now, let's move to the second method. We're done with the LSD. That's how you apply the LSD for randomized block design. We're still going to what? To randomize blocks by treatment interaction. So the take method taking method is given by, allow me to write two formulas here. Use any of the two. So the good thing about randomized block design, we're always dealing with the problems that are balanced, isn't it, guys? Yesterday, I think Mr. Lewo taught you that if the problem is having a missing value, you can estimate that missing value. And after estimating that missing value, the problem becomes what? Balanced. So here you don't have to worry about solving a problem with a missing observations. Because if you are given a problem with missing observation, you must first, rule number one, before you can do any calculation, you must first estimate that value using that formula that Mr. Luo showed you. So the take method is given by T alpha Q T, degrees of freedom of error, multiplied by the standard error, which is square root of MSE over B. Or this formula, if you don't like this one, you can use this one, Q T degrees of freedom of error divided by the square root of 2 multiplied by the square root of MSE 1 over B plus 1 over B. You can also use that one, guys. It's the same thing. It's the same thing, because if you take the this value, the square root of 2 to inside that square, the square root here, if you take this one inside the square root, it will cancel with the 2, isn't it? Because this will be 2 over B. So you can, it's either you use this one or use this one. It's up to you. So what we're talking about here, we're talking about what? Treatment means. Immediately you immediately divide by B here. It means you are testing for the treatment means. Immediately you divide by T here. It means you are testing for the block means. And Mr. Squattabraga just asked now, are you going to focus on the blocks? No, I won't. So that's why I'm saying whenever you're given a state, a problem, understand which one is your treatment. You don't have to memorize that. You understand which one is your treatment. Or even from the question, you'll be guided that use the means of the employees. So you must check where is the means of employees placed. If it's placed on the row side, it means you must know where to find the totals for those employees. So this is the formula, guys. The comparison is still the same. Someone's mic is, yes.
For the previous part, the LSD, what was the value of alpha?
What was there?
The value of alpha.
5%. It was 5%, my brother. And is the value wrong? The one that was given?
No, it's not right.
Oh, sorry, let me change this. So the table that you are going to use here is the studentized table, isn't it? So if you know this, guys, can someone give me the confidence interval for Teki? Can someone give me the confidence interval for Teki? As long as you have this part here.
The confidence interval of a check is going to be constituted into the treatment means the discrepancy
Why?
of the treatment means
Yes.
plus minus the T key the Turkey.
Like this, isn't it? Isn't it, Mr. Manyam?
Yes, sir.
Yes. So the confidence interval for Turkey will be like, it will be given by this. Are we cool? Now let's do an example now. We have the information, we know the formula. So the table that we are going to use is the studentized table, not the T table. So with the take method, you don't say T minus 1, you say T. The degrees of freedom of error agreed is 8. So let's solve the problem. Let's find T alpha. So T alpha is equal to, suppose we're using 5%, T of 0, 0.05 is equal to Q. How many treatments do we have? 3. Degrees of freedom of errors is 8. Square root of divide by 5 here is 0.201. Can someone remind me that standard error, please?
Oh,
Let's go, leaders.
11067.
0.67, right?
Yeah.
Like this.
Yes.
Thank you very much.
No,
So what?
this one, sir, between
What?
between
Yeah.
6. Yeah.
Okay. Like this. So what is this part from the table? Can someone give me this part from the table?
Yeah, it's 4,041.
4,041.
Yeah,
This you get it from
studentized.
Studentized. Right? You know the table that I'm talking about, the one that you use when you are dealing with the Newman Cairns method. You use the same table. So what is our take value here?
0.828.
0.828.
8.
Okay, it's fine. Now let's do the comparison. T1 and T2. 4.9. It's 4.9 or 4.6?
Yeah, it's
It's
4.9.
4.6.
4.6.
It's 4. The second one.
What is the first treatment? Is it 4.9 or 4.6?
4.9.
4.9.
4.9 minus 4, right?
Yes.
Is it greater than 0.828? The value here?
Yes.
Yes.
What is the value?
It's 0.9.
0.9.
Is greater than T alpha, isn't it? So this
Yes.
value won't change. T1 and T3, 4.9 minus 3.44. What is the value?
1.46.
1.46 is also greater than 0.828. T1 and T2 and T3, 4 minus 3.44. I'm waiting for you guys. Mathematics, remember.
0.56.
0.56.
This is less than 0.828. You know how to conclude, isn't it? So now, based on this, can someone give me the confidence interval using taking method? Using taking. For the first one, let's go. You have the information, guys, here. So it will be 0.9 plus or minus 0.828, isn't it, guys? Sorry. 1.46 plus or minus 0.828. 0.56 plus or minus 0.828. You see, you just get the information from, but be careful in a case where if these values were not inside the absolute values, you are going to get a negative value. Do you understand, guys? In a case where these values were not supposed to be inside the square, it were not in absolute values. In a case where it was possible to get a negative difference, you must write the value as negative something. So this is how you use the taking method. Any question? Any question, guys?
So, sir, on the confidence interval for the turkey, we are using the absolute values.
No. We're not using the absolute value. That's what I'm saying. If there's no confidence interval that you have to come up with the absolute values. All the
Okay,
confidence intervals, they don't have absolute values.
all right.
Because I think that is a common mistake. When you ask students to find the confidence interval, Homo can agree with me. They put confidence interval, they put absolute values. So please, when you are asked to construct the confidence interval, you must know that absolute values, they must disappear. So we are fine with the taking method. As I've indicated, I'll give you this document immediately after the class, in case if you want to.
So it's break time.
Today there's no break. So I'm having a visit, and maybe I can give you 2 minutes just to go and get something and come back. Let me give you 2 minutes. There's someone who's supposed to will need some of my time today. So the class won't end the normal way, it will end before. But you can go for 2 minutes. And then when you come back, we'll cover the Duncan method. We do the same. And then yeah, break for 2 minutes is fine. It's break time.
I know, sir. I just want to make a comment.
Yes.
You must teach like this every day, sir. You must write like this.
What do you mean now?
I mean, I agree with him.
Oh, so you're failing because of the way I was writing before.
Sometimes you don't write, you just talk, and we must figure it out on ourselves.
Oh, sorry, it's fine. Thank you, Mabunda, for that. We improve every day, isn't it? So break now, Mabunda,
Yeah.
you're supposed to be break. You were supposed to be out now. It's a smoking break.
Since it's break, can I please ask if you mentioned anything before you started teaching about the special test?
Oh, it's fine. The special test will be on Monday. Those who are submitted their letters, we have to agree about the time. What time are they free on Monday? Because I don't want you guys to write my test during someone's time. So those who qualified for special, we have to agree about the time that you can write that test. But remember, it's a face-to-face test. It's supposed to be between 8 and 4, because I cannot give you a test at 6 o'clock. Safety issues.
For us, who are doing computer science and stats, we only have one class on Monday. Yeah, one.
Yeah, one.
So
We
it
can
can
even
be
write
before.
before. We can even write before. So I know so far I was still waiting. I'm still waiting for my HOD to update me on how many students are supposed to write based on his record. Uh, if there are 5, I can try to maybe communicate with you guys so that we agree about the common time. Can you please resume, guys? Mr. Manyama?
Yes.
Yeah, we can continue, sir.
Or Mr. Mabunda, since you are still on the platform,
Yeah, we can
remind me about
continue.
the steps. Remind me about the steps of Duncan multiple range test. Step number 1.
We must first arrange the means according to.
Let's arrange them.
Yeah.
3.44, 4, 4.9. Step 2. Find the standard error, isn't it, Mr. Mabunda? What is
Yeah.
the
So
standard error now? The formula is there. What is your standard error? I was told that is 2,10167 divided by 5. We divide by B, right? This is what?
yeah.
When we divide this by B, what are you getting? Let's go, guys. What are you getting here?
0.205.
0,2.
05.
0. Oh, sorry. Like this. Like that, my leader.
Yeah.
Yes,
Sure.
sir.
Yeah, sir.
Yes, let's go to. Now we'll go to the Duncan's table. We have to go and find the ranges now. How many are going to find? 2, isn't it? R of 0,05, 2, and it's 8, isn't it? And R of 0,05, 3, and 8, because we have 2 treatments. Anyone who's having the Duncan's table closer to
Yeah,
him or her?
the first value is 3,261.
The second one?
Is 3,399.
99. So step number 4, you multiply the ranges with this. So R2 will be 3.261 multiplied by 0,205, isn't it, guys? R3 is 3.399 multiplied by 0,05. What are the answers?
Zero point six six eight
The
five.
first 0,6685. The second one?
The second one is 0,6967.
Thank you. So now we're left with the last step, isn't it? The comparison. Compare the means. That's where now during the test, hey, I noticed that when coming to this English language, hey, it was difficult for you guys to explain how do you compare the means using that Duncan multiple range test. Sure.
Sir,
Yes.
can you please go to the previous page?
Previous one.
Yeah, just 1 minute.
Yeah. I'm going to save this document and share it with you, my brother, immediately after the class.
Okay.
Yeah, I will give you these notes. Remember, I'm not projecting anything. I'm not going to give you any. I'm going to give you the things that we're discussing now. So when I'm done here, I will save this document and share it with you.
Sir, since you're saying
Yes.
you're having a visitor, afternoon the class is on or?
It's on. Afternoon class, that is the most important class that you should attend. Let's compare, Manyama. Largest minus smallest. Yes.
Sir.
Yes.
Are you saying this to
There's a class.
yesterday said there wouldn't be tutorial. Oh, this is a class. Oh, thank you.
Yeah, it's a class. A tutorial. It will be on Tuesday next week. We're going to use this one. We're going to use this today's class. We're going to convert that tutorial to be a class, and then next week to Tuesday we are going to convert it to be a tutorial, because we'll be having something to do on the tutorials, because already you covered the randomized block design last week. You covered the interaction effect last week. The only new thing that you didn't cover during the tutorial is when you are having a missing observation. So we cannot have a tutorial for you to just go and estimate a value, because after estimating that value, it takes you back to what you know. So largest minus smallest, what is the answer?
It's 1,46.
1.46.
Is it greater than R3?
Yeah.
Yes.
It's great.
Yes, greater than R3. Largest minus second smallest?
0.9.
0,
9.
9.
Yes.
It's also greater than R2, isn't it? Second
Yeah.
largest minus smallest. It's given by what?
0.56.
0.56 is greater than R2, isn't it? Looking at this, the confidence intervals, guys, for Newman curls. The other steps, if you are asked to construct the confidence interval, other steps that are very, very important. Yes, yes.
Hey, it's less than.
Yes.
This one is less than. Thank you very much. You see, this also applies to when marking, guys, or when counting the marks from your script. It's possible for me to do the right thing when marking, but when coming to the addition and subtraction there, I make mistakes. That's why we always say, when you collect your script, please check if everything is fine. So if you didn't collect your script by now, and then during the module mark time, you notice that we made a mistake, it will be a problem for us to solve that mistake, because you are given a window to solve all those problems. I can make mistakes, but you are given a certain time to check to correct that mistake that I have made. Like now, since the whole of last week, students were coming saying, yeah, no, you didn't count well. I was correcting those things. But if your script is still here in the office, and then you notice that I made a mistake during the module mark, it will be difficult for that problem to be corrected. Because immediately I submit the marks to my line manager, I cannot keep on going to him and change the marks, because when I submit the marks to my line manager, it means the marks that are recognized are the ones which are with him. So if you notice a mistake and then you don't report it now, it's a problem. So can someone so if you want to find the confidence interval for the first can I use the different color here? For the first one here, you will say 1.46 plus or minus R3. When you want to find the confidence interval of the second one, is 0.9 plus or minus R2. When you want to find the confidence interval of the last one, is 0.56 plus or minus R2. Which means are not the same there? Can you please check for me? Based on the confidence intervals. Based on the confidence interval, which means are not the same?
The first two.
So it's what and what? Yeah, you compared what and what? T2 and T3, isn't it?
Yeah.
This one you're comparing T2 and T3. This one is what? T2. Am I right, guys? Oh, this is T1.
Say.
It's T1 and T3.
And T1 and
Say.
T.
T2.
Yes. And the last one is what?
T2 and T1.
Say.
Yes.
Are we not supposed to compare T1 minus T2 with R3?
I said largest minus smallest. What is largest minus smallest?
I mean T1 minus T2. Are we not supposed to compare it with R3? 0.9.
What and what? What and what?
0.9. Are we not supposed to compare it with R3?
No. My brother, you ordered the means from largest to smallest, isn't it? So the first difference, you compare it with the largest range. When looking at this, what is your largest range here? What is your largest range, Matume here? What is your largest range here? It's what?
It's 0.69.
That's what I did, isn't it? That's why I said R3 here. Unless
that what the second difference is T1 minus T2.
T1 minus T2.
Yeah.
So you want to compare it with what?
R3.
Why R3? Even the first one you compare it with R3.
Yeah.
You say R3.
Hey.
No. It's wrong. It's wrong. Remember, this is RT minus. This is RT minus 1, isn't it? Go and check my notes. The second difference, you compare with RT minus 1. This is RT, isn't it, Matum?
Yeah,
The first
sure.
difference, you compare it with RT. The second difference, you compare it with RT minus 1.
Okay.
Do you follow, leaders? Do you follow what I'm trying to explain to Matum? My one is fine. Thank you very much. So, this is how you are going. Yes.
Nina question, so how we gonna be asked this thing of confidence interval for Duncan, because we have this one here, largest and smallest. So are you gonna be specific, or maybe we must do all of them once?
You mean how, Mr. Mabunda?
Because Aka, the one for a check, you were specific with T1 and T2. So for this one,
No, when I can give you a question, I say use the confidence interval method. Find the confidence intervals using the Duncan multiple range test. Find the confidence intervals using the Duncan multiple range test, and after finding those confidence intervals, indicate which means are not the same. So it means you are expected to do all these things, Mr. Mahmoud. You must do all these things from the beginning. You must start from here. You must arrange the means. But the important part that we need is this last part. But you cannot get here to the last part without these other steps, isn't it, Mr. Mahmoud? You need, for you to find the confidence interval, you will still need these things. You still need these things. So as long as you are asked to find the confidence interval, the only part that you won't give us is what? Is this part. If you are asked to find the confidence interval, because I don't need the pairwise comparison, I need what? The confidence interval. So immediately when you get to this step, you move to the confidence intervals. You say largest minus smallest plus or minus R3. Largest minus second smallest plus or minus R2 and so forth.
Okay, now I understand very well. Thank you.
Okay, thank you, brother. Yes,
Sir,
I'm
sir.
listening. Yes,
Oh, on that, go to the previous page.
the previous one, before this one. The
Down,
last page.
down this one.
Or this one.
Yeah, the last page.
Yes.
From second largest minus smallest. You're not
Yes.
supposed to say T2 and T3.
Which one? My sister,
Second
what?
largest minus.
Mean one is what? T1 is 4.9. T2 is 4. T3 is 3.44.
3.4.
So the order is T3.
The
T2.
first one is T1 minus.
So this is the order, isn't it, my sister? Yes, the order, yeah.
T1. Yes.
T3 is the smallest, isn't it? T2 is the second smallest. Am I wrong, my sister? And then T1 is the.
No.
So here is supposed to be 3, this one. Isn't it?
Yes.
Yeah, so
yes.
It's correct down. Eh?
Yeah. Thank you, sir.
T1 minus T2. T1 and T3 is the first comparison. T1 and T2 is the second one. The last one will be T2 and T3. She's right. I wrote 1 instead of 3. So it's supposed to be 2T, T2 and T3. So thank you for that leadership. So the means which are the same is mean 2 and mean 3. There is no difference between mean 2 and mean 3 based on our findings here. So the procedure, yes.
When you compare the means, where do you stop? Do you carry on saying RT minus 1? Maybe if we have like 5, when do you stop?
5
doing
meaning what?
When you have like maybe 5, the RTs, if you have like 5, when you compare the means, where do we stop?
You're saying
Like,
R, so it means you have R5, that means it will be 2. How many treatments do we have, my sister?
let's say maybe 6, I think. Maybe
Yeah,
6.
it's fine to be 6. R2, R3, R4, R5, R6. 1, 2, 3, 4, 5. Yeah, it's fine. So you say largest minus smallest, isn't it? Or let's put them assuming that this is the order, right? What is left? T5, right? Let's assume this is from smallest to the largest, isn't it? So the first order it will be T5 minus T2, T5 minus T4, T5 minus T6, T5 minus T1, T5 minus T3, isn't it? Do you see it, my sister?
Yeah.
So now, this goes back to what Matuma was saying. The largest range is what? It's R6, isn't it? Going down, isn't it? So it means R6, R5, R4, R3, R2. Isn't that like this? Isn't it? This is the largest, second smallest. So immediately we move to the next comparison. We get rid of the first largest. So the first thing you compare with R6, isn't it? R5, R4, R3, R2. Do you see it, my sister?
Yes.
You said the T5 minus. So you are done with the first comparison for the first part, isn't it? So you get rid of this one. Now, when you want to move to the next step, where now you want to compare the second largest and the other means, you get rid of this one, and you also get rid of this one. You understand my sister?
Okay.
So now we are
get
left
now.
with T3 minus T2, T3 minus T4, T3 minus T6, T3 minus T1, isn't it? How many values do you have? 1, 2, 3, 4. How many ranges are you left with?
4.
4. So you just attach R5, R4, R3, R2.
My
Now
issue
when
was that I kept the means. I kept using the same means.
No. Immediately you get rid of something this side. Like now when you want to move to the next range, if we get rid of this one, we must also get rid of X3. We minus this side. We have 2 crosses, even this side we have 2 crosses. How many ranges are left? If we are left with 4 means, it means you must have 3 ranges. If you are left with 2 means, it means you are only left with 1 range, isn't it? So the means are always more by an additional 1. Because now if you can check, if you check my sister now, how many means do we have? 1, 2, 3, 4. How many ranges do we have?
4.
1, 2, 3. You see? So means are always more by an additional 1. So if you have 4 means, it means you must have 3 ranges. If you are left with 3 means, it means you must be left with 2 ranges, and so forth. Do you follow, leadership?
Yes, sir. Thank you.
Thank you, my sister. So now I may have to move now to the next session where, so since you know how to apply these methods, I want to move to the interaction now. Balance block by treatment interaction. So this one we're not going to spend more time. I will give you the formulas, guys, starting with the LSD. Same procedure. You don't have to stress, guys. You don't have to stress with this one. Let's start with the LSD. So now we're talking about, so that you don't get confused when you're preparing, let me write the heading of this one. It will be block by treatment pairwise. Pairwise comparison methods plus their confidence intervals. I will write them and explain. When we meet during the tutorials next week, when you have more questions, you will ask. The LSD, guys, remember, sorry for this one. For the interaction, when we are going to have 2 formulas here. So we'll have the LSD for treatment. It means, remember, if we're talking about the LSD of the treatment, you will use the treatment means, isn't it? So the LSD will be given by T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over BR. Why now? Because we have the interaction, isn't it? Because we'll say now we modify that formula. Now, before you get to the interaction, you are saying 2MSE divided by B. So this is for the treatment. And the LSD again for block. So this one you must know it, guys, by treatment. The formula now will be LSD equal to T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over I. Can I please explain the logic behind these formulas? Why are we saying it's like this? Even if we don't do an example, but as long as you understand where we are going, it's like this, guys. Suppose I said the layout is very, very important. Layout of blocks by treatment interaction. We said suppose we have the blocks this side. 1, 2, 3, up to the B block. 1, 2, 3, up to the T treatments. Your model, guys, is given by Y, I, J, K. Check now. Now we have K. We must understand where we're going to use this K. Is given by, equal to mu, the overall mean, tau I, because the treatments are what? When you want to find the sum of the treatments, you are going to add the rows, isn't it? So Y, I, J, K. This one is the row. This one is the column. This one is the replication. That is why we say Yijk plus beta j goes with the column plus tau, the interaction effect. We are just multiplying the two. So you use their what? Their subscript, ij. You're getting them from here. Plus eijk, because it is here. The k is also here. So since you are going to have more than one value from each and every cell, remember, that's how you do the replication part, isn't it? If you are having a problem like this, in each and every cell, you'll have what? More than one value. So that's where the replication or the replication comes in for. This one can be 3. So you'll be having values here and so forth. You know the layout, isn't it? So when you want to find the sum of the treatments, you will add these values. You will add these 3 values, plus you add also this one, up to what? Up to the B block. So you find the answer here and the mean. So check here, guys, because you are focusing on the what? You are focusing on the rows, So when you want to find the sum of the first treatment, that's why you said it's Y, I. You are focusing on the rows. That is why it is there. You are not focusing on the blocks, and you are not focusing on how many treatments, how many replications do you have from each cell. Your focus is on what? Is on the rows. So that is why when we get back to the previous page, the formula, when testing, when you want to find the LSD of the means, you will say Y I dot bar minus Y I prime dot bar, isn't it? This is the difference between the means of the treatments. You are focusing on the I part. You divide by the part that is missing here. If you check, guys, we're saying yi dot we're saying I dot, and we agree that the second part goes with what? The block. The second part goes with the what? The replications. That is why when from the formula, when we check, is having what? It's having BR. You are guided by the dot from the formula. You are focusing on the treatment means. Now, if we want to find again the LSD for the blocks by interaction, you see, we're dividing by R. Why are we dividing by R? Here's the reason. Why not B? Why not TR? Your focus now, your focus is on what? Y dot Y I J dot. Remember these values. When you add these values from the first cell, it will be what? Y11 dot. What is not there is what? What is not there is the replication. So you say Y11 dot is the sum for the first cell. So what is not there is what? Is the K. K goes with what? K goes with the replication. That is why when we write the formula, we divide by what is missing there. So when you want to do the comparison for this one, you will say what? Y bar I J dot. So the means that we are going to use here, these are the means, minus Y bar I prime J, so that this is the different mean dot, because that is why even from the formula we'll divide by what? We'll divide by the R. So we'll do an example in the afternoon. First 20 minutes, I can do an example related to this section so that we move to Latin square design. Any question? Any question? Yes? Hello? Did you communicate with Okay, thank you. Yes, I'm listening. So I want you
here.
Let's do an example, it's fine. Can you please give me an example that you did with Mr. Law, which involves blocks by treatment interaction? Let's do a practical example. Yes.
Oh, sir.
Yes.
I want to ask if let's say we are doing the block by treatment interaction.
Yes. Yes.
Then we have to do the LSD.
Yes.
So let's say we fail to reject. Let's say we fail to reject the H0. That's why when we are doing the interaction, the block by treatment.
Oh, the interaction, yes, yes, yes.
Then we fail to reject. That's why we have to do the main effects, which is the fixed and random for both block and treatment, right?
Yes.
So I want to know if let's say we reject the treatment
when testing for the interaction.
Yeah, we fail to reject for interaction block by treatment.
Okay.
So we have to continue and
for blocks by treatment, you fail to reject.
We fail to reject
H0. Yes. And then you have to go to the main effect, which is blocks and treatment. Yes.
Yeah. So I want to know if we reject, let's say we reject the treatment means.
Yes.
Then the question says do the pairwise comparison. So I want to know if I have to do for LSD for treatment, but not for block by treatment.
Yes, you have to do for that one. If you fail, dear, remember, if you fail to reject the null hypothesis, no need for what? No need for pairwise, isn't it?
Yes.
Isn't it, my brother? If you reject H0 for the treatment means, you can do what? You can do pairwise comparison. So for this type of questions, expect pairwise comparison. Expect pairwise comparison or interconfidence interval for treatment, where you can ask to find the pairwise comparison for the treatment, or find the pairwise comparison for treatment by block for this section. That's what I'm saying. Looking at the time, it's no longer on our side. So I was thinking that you can, yes.
After failing to reject the interaction, which one then we test for treatment and blocks? Which one do we start with?
Any, because you have to. This one we call them main effect. Any is fine. Remember, why are we testing for the blocks? The blocks we are checking if blocks, you are checking the effectiveness, isn't it? Blocks, you are checking the effectiveness of the blocks, isn't it? But the treatment, you are checking if what? There is a difference between the treatment means, isn't it? Blocks, you are simply saying, by bringing in the blocks, did it improve my results? Do you understand? By bringing in the block, did it improve the result? If you fail to reject the null hypothesis when testing the blocks, you are simply saying the blocks were there, but they didn't help us that much. When you fail to reject the null hypothesis when testing for the blocks, you are saying blocks were there, but they didn't help us. You get it?
All right.
Yeah. So it's fine for now. Maybe you can ask questions in the afternoon. Clarity, wherever you need clarity in the afternoon, we'll do one example to cover all these 4 methods. The method that we just did from the first period, we're still going to do these methods again in the afternoon so that we conclude the chapter. So you can ask questions, it's fine. Yes, I'm listening.
Sir.
Yes.
So, which means if we reject 80 CADI interaction, which means we don't test for treatment and blocks.
Yeah, we don't test for treatment and blocks.
Okay, thank you.
But you can be asked to, even if you, let's say you rejected the null hypothesis, isn't it, for between blocks, for blocks by treatment. A follow-up question can come and say, check the difference between treatment means. But you are not asked to test for it. You are asked to check if there's a difference between some of the treatment means. So it is very, your question, my brother, is very, very important. And again, when coming to the test, guys, try to understand the given problem. For example, if you are asked to check for blocks by treatment interaction, the question is asking you to test only for that, isn't it? Even if you fail to reject the null hypothesis, don't go and test the other ones, because according to the theory is that if you fail, or let me just put it this way, let me, so that you understand it. In a case of blocks by treatment problem, let me show you the difference between the two. Suppose you are given a data set. Here's the question: analyze the data and draw conclusions. Two, let's take the or. I want to give you these 2 questions. Let me call it 1. Construct an ANOVA and use it to test for the interaction effect. Let's say you have what is the difference between these two questions, guys? This question, let me start with the second one. The second question is specific, isn't it, guys? That construct an ANOVA table. It's a block by treatment interaction effect, isn't it? Problem. If you are asked to construct the ANOVA table, it's fine. You will have the treatment, you will have the blocks, you will have the block by treatment, you will have the error, you will have the total, isn't it? But the second question is strictly saying test for what? Only test for F. Only test for this one, isn't it? The second question is saying test for this part, isn't it, guys? It's not saying that if you fail to reject, move to the main effects. No, it's saying, the question says test for the blocks by treatment effects. You are not asked to test for these other two. Even if you fail to test between blocks by treatment, you know the logic behind is that now you must come to what? You must come and test for these two. You can have the F values here. You can have the F values, but don't test, because the question is specific that only test for the interaction effect. You can fail to reject. You can fail to reject A0 or reject A0. But after that, you make a conclusion and then you do what? You stop. That is how the second question is structured. But let's go to the first question. The first question is like this. The first question now is tricky. It's tricky. Oh, sorry. The second question is tricky, guys. The second question, guys, it says, the first question, so sorry, analyze the data and draw conclusion. So this one now is flexible. If you're analyzing this data, you know the first step, you must start with what? You must start with the interaction. If you fail to reject H0, it means you must move to what? You must move to the 2, isn't it, guys? Because the question says analyze the data and draw conclusions. But the second question is specific that can you please analyze this data but only test for the interaction effect. The first one is silent about that. So for you to know if you also have to test for these two, you'll be guided by the findings from what? From the blocks by treatment interaction. Do you follow, guys, what I'm trying to emphasize here?
Yes, yeah, it makes sense, sir.
Yeah, so please understand what you are being asked, because we don't want a case where after writing you say time was not enough, but when we check your script, you didn't answer what you were asked. You decided to write what you know. Sometimes it's good to write what you are asked, not to write what you know. I thank you. Any question?
Yes, sir.
Yes, leader.
Sir, okay, let's say we rejected our interaction and we also rejected our treatment, which means we're no longer going to test for blocks.
You remember immediately when you reject for the interaction, you don't go to other questions, isn't it?
Let's say the question is the same as analysis of data. The first question.
That one again, again, you know the theory. The theory says what? If you reject, you start with this one, isn't it, my brother? Let's say you are given the first question, isn't it, Nkadimeng? You reject the null hypothesis about the interaction. You stop, isn't it?
Yes.
Isn't it, Kadme?
Yes.
You don't continue. You don't go and test for these two. If you reject, you stop. Am I wrong, Kadme? Or I'm confusing you?
Yeah, I'm confused. Auntie, we don't go to main effect after we have rejected the
No, it's the opposite. Is it not right, colleagues, leaders? How do you go to the main effects after testing for the blocks by treatments? You go after rejecting or after failing to reject?
We only go after failing to reject.
Do you hear it, Nkadimeng? When you fail to reject, then you can go to the main effect, the treatments and the blocks.
Okay, sir. Let's say we fail to reject. Then
Yes.
we fail to reject our treatment. We're still going to test for blocks now.
Yes, because immediately if you fail to reject, it means you must check if there's a difference between treatment means.
Yes.
You must check if there's a difference between treatment means. 2, you must check if the blocks were effective.
Okay.
Do you understand?
Okay, I understand, sir.
Thank you very much. So so please guys, whenever you read, so some of the students were consulting, I told them that when you prepare for an assessment, please but it's fine, I will explain in the afternoon. I'll explain when we meet for the second time in the afternoon. Someone wanted to come and visit you. I don't know what's happening.
So, sir, which means number 2, it does not matter if we fail to reject or we reject. We just end there.
Oh, because I get class teacher. Okay, so yes, the second question, it doesn't matter what you find, what is your final findings, because it strictly say yes.
It's me, Mr.
Oh,
Malek.
doctor. Okay, thank you very much. You can
Yeah,
talk to
it's
them, doctor.
me.
Thank you.
Yeah, I'm trying to look for how many students have attended here. Can you give
So
me the
far,
attendance then? Huh?
so far I'm seeing 109.
9. And they are
109.
305.
302.
302.
Yes.
Yeah, that is the reason why I am here. This is clear to me that there are even less than